Hey everyone, another recitation, this time for the class-based to-do app. So let's go ahead and get started. Over here you can see I've already started up the Yarn server and I have my React app in my browser. It's just our default. Let's go ahead and take a look. So I'm going to go into source and then check out my app.js, which is where everything really gets started. We can see app is already a class-based component for us. So this is the basic structure of our class-based components. Instead of functions, we write classes that extend React.component. And instead of directly returning JSX, we do that in a special function called render, because we can't return from within a class definition. So instead, all of our class-based components have a special member function called render, and that's what's called whenever we need to re-render the component, so that returns our JSX. So let's get started. Let's take a look at our README. So the first thing we want to do is look through our README and be sure we understand the requirements of our project. So we need to write this to-do list application where we can add to-dos, we can toggle the to-dos as completed, and then we can clear them. So let's grab this to-do data that they've given us as an example, and I'm just going to save this into a variable up here. Data. There we go. So now I'm going to have some to-dos to start with, which is nice, and we can already see they've helped us with the structure. Each to-do is going to have a task, it's going to have a unique ID, and it's also going to have this Boolean value of whether or not it's completed. So that's what we're going to use to toggle them on and off. Alright, so where do we want to get started? So within app, that's where we're going to want to store all the state for our project. And then we're also going to have a component called to-do list that receives the array of to-dos and then renders them all into individual to-do components. And that to-do component should take that object, display it, and then also contain the functionality, that when it's clicked on, we'll toggle it on and off. We'll also need a to-do form component that will house the input field and the buttons to add our to-dos. So I would like to get started by just getting something on the page. That's my first step whenever I start one of these projects. I want something on the page. I want to verify that what I'm doing is working. So let's start by getting our to-do data into the state of our component, because that's what we need in order, to get any data on the page. We have to have our data within our component. In our class-based components, we're going to do that inside the constructor function, which is what gets run when we create a new instance of any one of our class-based components. So we're going to start up our constructor, and I'm going to run super, which is what we should do whenever we're inheriting from another class. And then I'm going to make my state variable. We only have one state variable this time when we're using class-based components. So this .state, it's going to be an object. And I'm just going to give it a key called to-dos, and I'm going to set that equal to my to-do data to start off with. So nothing has changed. It's because all I've done is I've put my to-dos into my state. What I can do is I can make sure that worked by putting a console log inside of my render function, and then I can check my developer console. So let's see, there we go. I have my state object. It has the to-dos key, and then inside of that is an array full of my to-do objects. So I want to get these on the page. So I'm just going to try to do a proof of concept thing. So I'm just going to try to map over this .state, .todos. Remember, we're using classes now. So to access state, which is a property of my class, I do this .state. And then to access the to-dos key, well, state is just an object, so it's .todos. I'm going to map over this because it's an array. I'm going to get an individual to-do. Then I'm just going to make a div that displays the to-do's task. Because this to-do is one element out of this array, it's an object. I want to get the task key out of it. So I'm going to do to-do.task. Let's see. There we go. So I have some stuff on my page. So I know I'm headed in the right direction. I'm able to access my state variable inside of my render function because this is a class, so I can reference properties of my class using the this keyword anywhere I want inside my class. And then to-dos is still just an array, so I can use my old array method solutions to make some divs. We're still using the same JSX, so we have the same curly brace syntax within there. Alright, so that's feeling good. So why don't we go ahead and try to make our to-do list component, which is going to do what we did here, but a bit more officially. So I opened up the components directory. I'm opening up to-do components. And I'm going to see they already have some of these laid out for us, which is good. So let's look at these to-do list. Alright, so we have nothing yet. But we're going to start just like normal. We have to import React from React. And this time we do this slightly more purposefully, because to declare a component, instead of writing a function, we're going to write a class. Class to-do list extends react.component, and that is capitalized. I can never remember that. So here we have our class, and we still have to export it like normal. When we were writing functional components, we would import React from React, and then we would never use, this capital React thing, which is kind of funny. We needed to import it in order to use JSX, but here we actually use it to extend react.component. So finally, we use that capital React. So now we're going to write our component. We're going to start by writing our constructor, but this time it's going to take in props. So our functional components would take in props as an argument to the function itself. When we create a class, if you remember way back in the day when we wrote our vanilla JavaScript classes, whenever we make a new class, we do, new, let's just do a to-do list, and then we'd give it arguments, and these would be arguments that are given to the constructor for our class. That's the same thing that's happening here. When we render a class-based component instead of a functional component, instead of just calling the function with arguments, we're going to call the constructor with arguments. And in this case, it's going to be our props object that has all of our, keys and values in there. So our constructor is the thing that takes the props. That's where our class receives arguments the first time we render it. So I'm going to call super and give it my props just to make sure that react.component does whatever it needs to do with those props. And then now I'm going to define my render function, which is going to do the actual rendering. It's going to return the JSX that's going to show up on my page. And for now, I'm just going to return a div that says to-do list. Because I want to see, I want to constantly prove to myself that I know what I'm doing. So I've just tried to write my first from scratch class component. So before I start trying to get into the weeds with everything, let's just see if I can get this to show up on the page. And let's just see it behaves in the way that I expect. So if I want to render this component within app, if I want to use this component within app, I'm going to have to import it. And that's the same as it used to be. So I'm going to import to-do list from, and then my relative path. So from where I currently am in app.js, I'm going to need to go into components, then to-do components, and then I'm going to get the to-do list.js. And then to render that, it should work the same as my old functional components did. Funny calling functional components old. And then I just render it like any other component, just between my angle brackets to-do list within my JSX. All right, there it goes. We got it. We got it. We've written our first from scratch class component, and we've gotten it to show up on our page. Well, now I want to give it some props, because I want my to-do list to do essentially what I'm doing here. I want it to take in my array of to-dos, and I want it to put those on the page for me. So let's check and see how props work. So I am going to give it a prop. I'm going to call it to-dos, just to be consistent. And I'm going to give it this value, right? This .state.todos is this array. It is my array, and that's what to-do list needs access to. So I'm going to give it this .state.todos. And then in here, I'm going to console log my props to see what has happened. And I'm just going to add a little tag on this to make it easier for me to find within my console. So we see it shows up. I get my props console logged, and it's this object with nothing in it because I forgot to save app.js. So I see it show up in my console, and it's this object that has the to-dos key in it with the array I've given as the value. So props still work the same way. When we render the component, we give the prop a name, to-dos, and a value, this .state.todos. Then when we get our props object inside of our component, to-do list, we get an object with a key of to-dos and a value of that array. So that still works the same. But now I want to map over this, and I want to do this inside of my render function. So let me try to console log my props within here. I got an error. It's trying to tell me that props isn't defined. But what, I have props right here. Can anyone tell me what has happened here? Why is it telling me that props aren't defined on line 11? When they were on line 8, I just copy and pasted that line of code. I see some typing. Yes, exactly. So, unlike our functional components, we don't have one big scope that we're working in. Props is defined within the scope of my constructor as this, props variable, but it's not defined within my render function. However, if we want to share data between these parts of our class, that's why we have our this object. So I should be able to console log this.props. And let's see, there we go. So now I get this object that has the to-dos key and the array in it. But wait, you might be thinking, I didn't ever define this.props, so how do I have access to it? Does anyone know the answer to that? Where am I defining this.props? This is a tricky one, because I have not written the line of code that does that. That was not me. Yes, Eli, great. Yes, super props. When we call super, we're calling the constructor of the class that we're extending, of the class that we're inheriting from. So when I call super props, this is going to do the default behavior of a React component, which includes defining this.props for me. So as long as I use my super, I don't have to worry about doing that myself. So now I can, within here, render my list of to-dos. So I'm going to do this.props.todos to get my array. I'm going to map over it. I'm going to take one to-do, and then I'm going to make a div that contains its task. And there we go. And it shows up twice because I don't really need to be doing this within my app.js anymore. I have my to-do list to do it for me. Alright, so now we've got this showing up onto the screen. We're making our incremental progress. So to-do list works, but I don't really want to be making these divs. I want to be making to-do components that's going to handle the nitty-gritty of actually getting these tasks displayed on the screen, but then also allow me to add on-click events to them so I can toggle them on and off when we get there. So let's look inside of our components, to-do components folder, and let's find todo.js. And this time we're just greeted with a blank file. We're going to have to make our class-based component really from scratch this time. So same as always, I import React. From React, I'm going to define my component as a class, extends react.component, and then I'm going to export it. So within here, I'm going to define my constructor function, which is going to take in props as an argument, in the same way that our functional component would take in props as an argument. I'm going to call super with those props to let React take care of the standard stuff for me. And I'm going to define my render function, which is going to return some JSX. So let's take a look at our to-do list up here. And let's, I saw a quote the other day that I really loved from a textbook I enjoy. And I'm going to butcher it here, but we can use a very powerful tool in development known as wishful thinking. So I have not written the to-do component yet, but I can assume that I have, and I can assume it works in certain ways, and I can implement it top-down. I can try to use the to-do component in here, and then guide my implementation of that to-do component based on how I decided to use it. So, instead of making this div, let me format this a little bit nicer. Instead of making this div, I don't want to make a div here. I want to make a to-do component. Well, and I want it to render this lowercase to-do that I'm getting, from my array. This object that contains all the data for that. So I'm going to need to pass that as a prop. So I'm going to call it to-do, and I'm going to give it to-do as its value. And I can delete this old div. I don't need it anymore. Alright. So now I've just engaged in wishful thinking. If the to-do component was implemented the way I hope it will be, then it will take in this to-do object, and it will render all it needs to do. So I can use this to guide my implementation, because now I recognize that I should have a prop called to-do, and that should be my object that has, all the data that I need to render this to the screen. So I can return a div, and I can put inside of it this .props.todo.task, because this .props is my props object, to-do is the name of the prop that I decided here, its value is one of the objects from my array, and each of these objects has a key called task, and its value is the actual string that I want to display on my page. So I save this, and I save that, and I get an error. And that's because my wishful thinking is wonderful, but I still actually have to import the to-do component. So I'm going to go up to the top of my file. I'm going to import to-do from my relative path. Where I am, the to-do file is right next to me. So I can just import it from /todo.js. Now when I save the page, I get another error, because I just wrote console instead of console.log. Okay, so with that corrected, now this works. My app.js passes down as props my array to my to-do list. My to-do list maps over that array and renders a to-do component for each one of these. And then my to-do component goes ahead and actually renders the contents of that to-do. I can check my console and see I'm getting this warning. I've been a bit relaxed about fixing these warnings in the past, but no longer. If you see one of these, it's usually a very easy fix. All this means is I'm doing a map, and I am not giving each component a unique key prop. So, for each to-do, I need to give it a key prop, and this needs to be some unique value. Do we have a unique value for each one of these to-dos? Yes, we do. If we look in these objects, they all have an ID, and the ID is guaranteed to be unique. So we can use that as our key. And most of the time, we have this warning about lacking the unique key prop. All we have to do is give it a key that's equal to the ID of whatever object that we're ultimately rendering. So my warning goes away, and I'm all good. Okay. So, what next? I have my to-dos on my page. What would you all like to see next? Would you like to see me get the toggling working? Or would you like to see me get the form working? Alright, Vanessa's asking for the toggle. Vanessa got in there first. We'll do both of them. We have time. But let's get the toggle working. So, I noticed when we were in this components file, we also have this todo.css. Oh, I was hoping it had the CSS for the toggle in it. It doesn't. But this is CSS that we can import and then use within our React application. So let's figure out what CSS we want. If we reference the GIF that we were nice enough to be provided, when we toggle these, we get a line through them, also known as a strike through. So we can Google CSS strike through and figure out what we would need to add in order to get that behavior within our own app. Turns out there is a prop called text decoration, and we can set its value to line through, and that'll give us what we want. But I don't want that on all of my to-dos. I only want that in the ones that are completed. One way to do that is to make a class called completed. And anything with that to-do with that completed class, I'm going to set text decoration to be line through. So now my goal is to make any of the tasks that I'm rendering, any of them that are completed, I want them to have this completed class on them so that I can apply the CSS to them. Because right now there's nothing. They don't have any classes. So, how can I do this? Well, I can add class name as completed right here. Huh. And that didn't work. Does anyone know why that didn't do anything? I clearly wrote the nice CSS that I need here. But I'm not actually using this CSS anywhere. Yes, Kevin, I need to import it. So I wrote my CSS in this file, but to actually include it with my React application, I need to import it. So I'm going to import my todo.css. And then now, great, those have lines through them. But I don't want all of my all my tasks to have those lines through them. So I only want the ones that are completed. Well, if we look in app.js at our sample data, they have this Boolean value completed as either true or false. In this case, both of these are false. I'm just going to make this one true. And I want to use this value this completed value to determine whether or not I add this class name to my component. How can I do that? Well, whenever I'm trying to decide between doing something or not doing something inside of my JSX, that usually means I want the ternary operator. So what I'm going to do is I can set my class name equal to a JavaScript expression with these curly braces, just like I can with anything else in my JSX. And I'm going to say if this.props.todo.completed. So if my todo object has a value of completed that is true, so if it is completed, then I want the class to be completed. Otherwise, I'm just going to make it an empty string. So now, when we render these objects, what we're seeing is the first one, we can right-click and inspect on it. It doesn't have a class. But our second one that is completed, where this.props.todo.completed is true, it gets this class completed. So now it has this strike through. So now I'm set up to trigger my click functionality however I want, and then get visual feedback that it's working. I like it when stuff shows up on the screen. It's good feedback for me to know if I'm doing things correctly or not. Now what we need to do is actually write that functionality. So what we're going to do is we're going to write a member function on our app. Because ultimately, what we need to do is we're going to need to, when one of these tasks is clicked on, to modify the value of our state variable to flip the completed value of that task on or off. So let's do that. We are going to add a member function, which we're going to write using our arrow function syntax. That way we don't have to worry about this rebinding. So what do we want to call this? Toggle completed. That sounds good to me. So for now, I don't really know what I want to take in as an argument. So I'm going to leave that blank, and I'm just going to trudge on ahead. And as soon as I get stuck, I'm going to try to think about that a little bit more. So I have my toggle completed function. What I want it to do is I want it to modify one of the to-dos inside of my array and change the value of its completed. So one way to do that is, well, I could use a map. So this .state.todos.map, and this will allow me to make a new array, and I can perform whatever modifications I want on whatever to-dos I come across. So I'm going to get my to-do, and then I want to return my to-do with some kind of modification. But, I want to flip its completed to the other value. So I can do this with the not operator. So whatever the value of todo.completed before was, I want to turn it into the opposite of that. And I can do that with my spread operator syntax to make a new object, but set the key completed to have a new value. The problem is that when I do it inside of this map, it's going to perform this operation on every single one of my to-dos. But I don't want to do that. I only want to do that on one of them. That's where the argument that I left kind of hanging until now is going to be used for. Because I want to be able to give some piece of information here that will allow me to identify which to-do I actually want to change. So what if I were to pass in an ID here? Because I have access to the ID inside of my to-do components, because I have my whole to-do object, and inside of that to object, I have an ID. And I know that's guaranteed to be unique, so I can use that to figure out if the current to-do that I'm looking at inside of my map is the one that I actually want to change the value of. So I could add an if statement here. If the ID I was given matches the ID of the current to-do that I'm looking at within my map, then I want to modify its completed value. Otherwise, I just want to give that same to-do I got right back. It's fine. Don't need to do any modifications. Just use the same to-do. Now, some of you might be looking at this a little bit confused because you did it differently. You might have used find or find index or any other of an unimaginably large ways of solving this problem. And there are different ways of doing this. There's perhaps even better ways of doing this, but it's a one way of doing it. So I wanted to show you this way. So we can do it with this map and an if statement to find the to-do that we want to modify, and then we're going to flip the value of completed on and off, which is going to change whatever class it has, which should apply the different CSS. But now I need to trigger this when I click on one of my to-do items. And I do that by passing this function down as a prop. First to to-do list, because to-do list is going to render all of my to-do components. So I'm going to add a prop to this. We'll call it toggle completed for consistency, but I could call this whatever I want. And then let's spell this correctly, toggle completed. My editor is saying that toggle completed is not defined. Does anyone know why? I clearly defined it right here. But it's telling me that it isn't defined, and I'm pretty sure I spelled it correctly this time. Yes, this. We're writing class components now, so we don't have our one big scope to define things in. If we want to share stuff, we have to put it onto our this object, which is what I actually did here. That's what this definition is. Notice how I didn't write const. If I write const here, I got a whole mess of errors. So I didn't write const. This adds this member function to my object, and then I can reference it with this .toggle completed, and because it's an arrow function, we won't get any of this rebinding, so we're good to go. Now, inside of my to-do list, I should be receiving, if I check my console, a new prop. Yep, I get this toggle completed key, and its value is my function. I don't really care about this in my to-do list. I just need to make sure it gets down into my to-do component. So I'm going to add a prop to this called toggle completed. Well, ooh. Sometimes you spell something so wrong you just have to start over. So I'm going to add a prop called toggle completed, and I'm going to set its value to be this .props.toggle completed. Now, within my to-do component, let me pull this up on the other page. Within my to-do component, I now have access to this function. So I can add this as an on-click for my div, right? So whenever I click on it, we fire this function, right? So I'm going to set my on-click, and then I'm going to call this .props.toggle completed. And this should work, right? It should definitely work. Whenever we click on this, it'll run my toggle completed function. It's not working. Well, how should we go about debugging this? I'm not getting any errors, so I think I'm doing everything correctly. Let's check out our app.js, where we defined our toggle completed function. What if I put a console log in here, just to check and make sure that this is actually running? So when I click on one of these, oh, my console log fires. I see that I'm running toggle completed right here. If I click on these, it runs again. So that's running. It's weird, right? My function's running. Why isn't it doing anything? Yes, Jason, I forgot to pass the ID as an argument. Right now, when I have it in my onClick handler, I'm just running this function whenever I click on it. And by default, when we run our event listener, it's given an event as an argument. So the next step I would want to take in debugging this is, well, I'm running this. Let's check and make sure all the values that I'm receiving are what I think they are. Because JavaScript, we don't have types. I just decided to call this ID. I have literally no enforcement in place to check and see if this is an ID. So this is something I want to do manually. I can console log this ID. And now we see when I click on one of my to-dos, what we get back is our event object. And that should be a pretty bright clue to us that we forgot to actually give an ID. We're getting this. So instead, the function I want to run when we click is this anonymous function that's going to call toggle completed with the to-do object's ID. So I'm going to give it this.props.todo.id. So now when we click, we run this function, which can take an event as an argument. That's what it's going to be given. We're not using it though, so I don't have to write it there. And then it's going to run my toggle completed function with the to-do object's ID as an argument. So now, when I click on this, it's going to run toggle completed, and it's not going to work. So, why didn't it work? I'm running it. Now I'm giving it the ID as an argument. I'm mapping over my state, and I'm creating a new array with this in here. Why isn't it working? Why isn't it doing anything? Yeah, Dora. This set state. So I mapped over my state object. I mapped over the to-dos, which is very nice of me. The result of line 30 and beyond is to create this new array, but I don't do anything with it. It's just kind of hanging out there. Like, great, we did it. If I want to change the value of my state variable, I have to call this dot set state. And that's going to set the value of my state variable to be what I've given it. It's very similar to in our functional components where we have a state variable and then set whatever we called that state variable. Here, our state variable is always called this.state, and our setter function is always called this.setState. So this is also always going to be an object. I want to set the value of the to-dos key to be the result of my map here. And let me try to get this formatted a little bit nicer. I don't want that semicolon there, but I do want one here. So now I'm calling this .setState, and I'm giving it my updated state object, where to-dos is now equal to the result of this map, and this map is going to go out and modify the to-do object that I clicked on. Hopefully. Now let's see if this works. We did it. We have finally done it. When I click on one of these to-dos, I call my toggle completed function and give it the ID. Then I update the value of my state variable. I update the to-dos key to be a new array. And in this array, I find the to-do with the ID that matches what I was given. I flip its value of completed, and then my state updates. This does its wonderful React thing where it re-renders what it needs to re-render, and the classes are going to flip, so these are going to be marked as completed or not completed. So, any questions here? No, are we feeling good about this?
Just one quick question. Since app is managing all of your state, I'm just wondering why you opted to make to-do and to-do list class components versus functional components.
Ah, you could absolutely make them functional components. The difference between a class component and a functional component when there's no state in them isn't really relevant. In the past, if we wanted state, we would have to use a class-based component. But if there was uh, no state, then we could use a functional component. You know, before hooks existed, we were still allowed to write components that are functions. They just couldn't have state in them because there was no mechanism to do that. So I absolutely could have made them functional components. I chose not to because I wanted to get that extra practice in of what would these look like if they're class-based components. How do I interact with props in a class-based component? So that was just a choice that I made in order to increase my skill. Because I also don't write class-based components too often anymore, so I could use the practice, and I'm guessing you all could too. Does that answer your question?
Yeah, absolutely.
Okay,
Thank you.
great. Any other questions before we move on to the form? All right, cool. Let's get our form going. So, if I look inside of my components folder, they already have a file for us ready for our to-do form. I'm going to start as I always do. I'm going to import React from React. I'm going to define our component. I'm going to make this class-based because I know the instructions say that app should manage all our state, but I'm going to do some state in this one. You can't stop me. So I'm going to make a to-do form. It's going to extend React.component, and then I'm going to export it. Then in here, I'm going to make my constructor. It's going to take in props. It's going to call super props. Then I'm also going to define my render function, which is going to return my JSX. And in here, let's make a form. And this form is going to have an input, or type is text. I'm going to call it, I don't know what I want to call this. New to do. And let's put a placeholder in there. And then I'm also going to add a button where type is submit. And let's add a new to do. Okay. So to get this to show up on my screen, I'm going to have to import it in app.js. So I'm going to import to do form from /components, to do components, and the to do form file. And then I can go down to my render function and render it just like any other component. There we go. So I have my little form here. I can type in there. I can click on my button, and it does its default form things, which is definitely not what I want it to do. So I know the instructions said we should manage all of our state in app, but I'm going to do our traditional managed form stuff inside of our class-based component because I want to get some reps in. I want to see what that's like in a class-based component, and then I can always pass that value up in my onSubmit event. So that's the way I'm going to decide to do this. So I'm going to make my state variable. It's going to be an object, and I'm going to set a key in it equal to the name of my input. Let's call it new to do. And its initial value is going to be an empty string, which is important because I'm going to set the value of my input to be from that state variable. So the value of this input is going to be this.state.newToDo. And this is very similar to the way we did it inside of our functional components. The main difference is that we have this in front of our state variable. it's important that I make this an empty string because let's say I made this undefined. Well, when we pass props, those all get collected into an object, right? And then we do, our props object dot whatever our key name is. And if we passed a prop, it's going to give us a value. And if we didn't pass that prop, it's going to give us undefined. So if I try to set the value on my input via this prop, and the value I give it is literally undefined, it isn't really going to know whether I actually wanted to pass a value in there. So I have to make sure that what I'm giving it from the start is some value. In this case, an empty string. So it knows that I want to manage this form. It knows that I want to set its value to be whatever is inside of this variable. So it's very important that I start out with that empty string there. And now when I try to type in here, nothing happens. Because the value of this form is always going to be this empty string. So I need to write my handle change function in order to update the value of this variable. So I'm going to write my handle change function. It's going to take in an event, and then it's going to do all of our normal things. Instead of calling set whatever, we're going to call set state. And we can use our old tricks. The name of the key is going to be event.target.name, and its value is going to be event.target.value. So now when I type in here, it didn't work. It's because while I have written my handle change function, I haven't used it anywhere. So I'm going to need to add an event listener on change, and I will give it my handle change function, which isn't defined because I'm in a class, so it has to be this dot handle change. So now when I type in here, I will trigger my onChange event listener. It will call my handle change function, which will take the event, and it will update my state using the same old tricks we've learned, but with this where it's appropriate, essentially. So now, just like any other form, I'm going to need to write my handle submit function, because I don't want it when I submit the form for it to refresh and for it to modify the URL with the contents of my form. Jason asked, since set state leads to a re-render, does using handle change cause a re-render for every keystroke in the input? That's a great question. It's also a testable question. So, when we re-render our component, what are we doing? Well, we're running this render function. So let's check. Console.log render. Render. So, let's see what happens. So we see it fire once when we initially render our form. And then, whenever I type in here, render triggers again. So yes, every time we call setState as a result of typing into our managed input, it will re-render the component. And you could actually see, before I did this, I'm not sure how well it's going to show up on the Zoom screen share, but it should appear in the recording. If I jam on this fast enough, you will see, yeah, there we go, the pop-up box appear where Firefox is trying to complete the value. Because for a split second, I am actually typing into the form. I am actually trying to type stuff in there. But we immediately cause a re-render, and that is going to set the value of the form again to be our empty string. But when we do our managed form, it's now going to set the value of that form to be the new thing that we have put in there. And that does trigger a lot of re-renders, yes, but this is where we rely on the efficiency of the React devs, because they don't just reconstruct the entire page when this happens. They manage the virtual DOM, and they see the differences between that and then the real DOM that's being displayed to the user, and the only thing they actually do is change the value of this form. Kevin is asking if I could briefly go over the bracket notation on line 12. So let's remove these. I start to get errors all over the place. And that's because whatever I put before the name, whatever name I put before the colon inside of my object is going to be the name of that key. But let's say I want to use a variable here. I don't want it to be just some static key name or something. I want it to be the value of a variable. Well, even if I write some variable, I can't just reference it here because JavaScript is going to interpret this key name to be the literal value, the literal string key name, and not the value of my variable. So we just have this arbitrary syntax that if we wrap this inside of a set of square brackets, it will interpret whatever's in here as a variable name that it should go out and get the value of, and that should be used as the key name. So we're able to get event.target.name, which coincidentally I set the value of this name prop on my input field to be new to do, which is the same name as this key inside of my state variable. And you can remember this because it's similar to if I have some object, if I want to get the value of the key name, I can do object.keyname, right? That works. But what if I want to get the value of some variable name out of this object? We do that with the square brackets, right? So if I wanted to get the key var's value, which is key name out of this object, I can't do .keyvar. It will actually try to get the key named keyvar. If I want to use the value of that variable, I do it inside of square brackets. So this is just roughly analogous to the square brackets accessor operator on our object keys when we're defining objects.
Yeah, so is it still considered bracket notation, or is it something else?
So bracket notation is not really a specific thing. We are using brackets in the notation that we are writing, but I'm sure if you look this up on MDN, it has its own specific name. This place where we're using brackets is probably something like the object key accessor or something like that, object key operator, I don't know. And here, this also has its own name within JavaScript. This is just something that developers of the language have decided to give us so that we can use object names, use variable names inside of our object definitions. So, Vanessa just told me the bracket notation here is called a computed value. Yeah, so it's letting us basically compute a value that we want to use as the name for our key, rather than just using a static string value there. So that is what we're doing here. And these are different things, but they look the same, which is nice because they mean roughly analogous things. We're using the value of the variable here, not the static key name. So
in short, that notation would be useful whenever you want to create object keys with variables as opposed to the actual literal string.
Yes, that is absolutely correct. So that is how we get our handle change going. So now in our handle submit, I want to prevent the default behavior so that it doesn't refresh my browser when I submit the form or modify my URL. And now I want it to actually add the to-do that we've written in there to our state. So we're going to have to do that by passing down a function that modifies the state variable in app to our to-do form. And again, I'm going to do my wishful thinking. I'm going to design this top-down. So I'm going to define a function called add to-do, And this is going to take in some text. I'm going to call it task. And then what this is going to do is it is going to call this .setState because I want to modify my state. I'm going to update the value of the to-dos key. And what I want is to add something onto the end of this array, which I'm going to do using my spread operator, because I'm just going to make a copy of my this.state.todos. Ooh, spelling is really hard. This.state.todos, and then I'm just going to add a new element onto the end of it. And it's going to be an object that I want to be in the same shape as the objects that I was given initially. So it has a task, and that's going to be equal to some string. It has an ID, which must be unique, and the README tells us to use date.now to generate that. And then it also has a value of completed, which says whether it's completed or not. Initially, this is going to be false, because we're adding a new to-do. So I can construct this object. It's going to have a task, which is equal to this task value that I've decided to pass in. It's going to have an ID, which is going to be date.now, which gives me the number of milliseconds since the 1970s, which, as long as we don't submit two to-dos within the same millisecond, we're probably safe on that being unique. And then I also want to give it a value of completed, which initially is going to be false. So this is all it takes to add a to-do to my array. I'm going to then pass this down to my to-do form as a prop. So I'll call this add to-do, and I'll give it this dot add to-do. We're in classes. I need this to access my member function. I'm going to save this, and then inside of my to-do form, I am going to call this dot props dot add to-do, the function I was passed via props, and then I'm also going to give it the value that I've written in my form as an argument, the text that this function expects. So I'm going to give it this dot state dot new to-do. So now I should be able to type in here, and we're adding the value of this to our state. And then when I click submit, it should trigger this function, which will prevent the default behavior and then add the to-do to my state. I also need to add this event handler here. So on submit, I want to run my this.handle submit function. So I'm going to add a new to-do, hit MVP, and when I click add a new to-do, there we go. We got that added to our state, and React does its wonderful thing to make sure that we render this new to-do, and we're all set. I want to do one other small thing, which is I want to clear this form when I submit it, which is very easy to do when we have these managed inputs, because the value of my input is this variable. And it's very easy for me to modify this value of this variable using this .setState. If it were just part of that input, then I would try to have to figure out how to get that input, from my page and then set its value, which might lead to me doing things like document.querySelectors, which is something we don't want to do in React. But since I have access to it inside of my state variable, I can change it using the React tools that are set up for me. So to clear this, all I have to do is call this .setState, and I want to change the value of new to do to be an empty string again. So now, when I add this, it clears the value of my form. And there we go. So then, I know I've gone over just a little bit on time here, but I would like to implement filtering really fast if I can. So let's go ahead and do this. So I want to be able to clear all of the completed to-dos from my list. But before I do this, do we have any questions? I'm sorry, do we have any questions with what I did with that form? No? Are we feeling good with that? All right. So let's add filtering really fast. So I want to have it so that when I click on a button, I'm going to add inside of my form. I want, when I click on this button, to remove any completed to-dos from my list. So the idea here is that I'm going to need to modify my state variable in my to-dos array and remove any items that are completed. So this is a great, wonderful, perfect use case of filter, because just like with our functional components, we don't want to modify state directly. We want to do that within our set state functions. So that's why I decided to use map here. It's always a good idea for me to use these array methods or other functions that don't actually modify the value. They rather produce a new value that contains the stuff that I want. And that's exactly what filter does. Filter is going to produce a new array full of only items that pass some test that I give it. So let's go ahead and I'll do this right above my toggle completed. Let's call this filter completed. So this is going to be a function that needs no arguments, because all it's going to do is it's going to filter over my to-dos array and remove any of them that happen to be completed. So I'm going to call this .setState, and I'm going to give it an object where I'm setting the value of to-dos to be the result of calling this .state.todos.filter. I want to filter this array. Now filter is going to take a callback function, and this callback function is going to take one element from my to-dos array. I'm going to call it a to-do. And now what I need to do inside of this callback is I need to return true if I want to keep it, and return false if I want to remove it. I can use my completed value for that. If I want to keep something, if the completed value is false, then I want to keep it. If the completed value is true, if it's done, then I want to remove it. So what I can do is I can check and see. And I'm going to do this wrong and then progressively make it more right. So what I can do is I can check and see if the to-do is completed. If it is completed, then what I can do is I can return false. If it is completed, I want to remove it. And if my callback function inside my filter returns false, then it will get removed. Otherwise, else, I want to keep it. So then I'm going to return true. So this will work, but this is a pattern that whenever you see yourself or someone else writing this, it should jump out in your brain. If you're checking the if value of something directly and then returning either true or false, chances are that you don't need the if statement. You can just return the value that's inside the if. But we need the opposite value, because if this is true, we return false. If this is false, we return true. Thankfully, we have a neat little operator that will give us that opposite value. So instead of writing, 5 lines of code technically, we can turn it into one. Return not to-do.completed. So, is it always a good idea for us to try to write our code as small as possible? No, that's not the point I want to get across here. But instead of writing 5 lines of code, I'm able to write 1 line of code, which we can read quite easily. We're just returning if this isn't completed. If it's not completed, we keep it. If it is completed, then we don't. That's a lot easier for me to read than this whole big if statement, and it also gives me less chances to write bugs. So this is one case where writing our code simpler and clearer is better, right? Very easy to read this, very easy to reason about what's happening here, instead of this big if statement. which, yes, it's a bit more explicit if you're new to the language and not comfortable with an operator like not. But ultimately, this is going to be nicer code to revisit in a few months. Because you in a few months is effectively a different developer. So, I'm going to just return not completed. If I really wanted to, I don't have to use the explicit return. I can just use my implicit return arrow function. This is where it starts to get less important to me, whether or not we're writing shorter code. Either one is fine. It doesn't make a huge deal. You know, characters are not precious, but my time is. So when I'm reading this, if it can read simpler, cleaner, more clear to me what's happening, then that's good. If we're just saving on the number of characters we have, it's not a necessity, but some developers prefer to write it the other way, and they are not wrong. In fact, I would prefer to write it the other way. I've just written it this way to be explicit. So, thank you for following along with my tangent. So now I have my function which filters my to-dos and sets the state to be that updated array. Now I can pass this down into my to-do form as a prop. So, filter to-dos. Is that what I called this? It isn't. I called it filter completed. And you know what? That's fine. I can name props whatever I want. So I'm going to add a prop called filter to-dos, and I'm going to give it a value of this dot filter completed. Doesn't matter what I call this on the left-hand side. I can call it whatever I want. I just have to, when I use it inside of my to-do form, be sure that I am referencing it with the appropriate name that I put on the left-hand side here, the name of my prop. So when I click on my clear completed button, I want to run my this.filter completed function. So now, when I do this, usually when something goes wrong, I'm prepared for it to happen, and I anticipate it. Oh, I know what I did. I forgot to put props here. I went on this whole big rant about getting things from our props correctly, but this dot filter completed is not defined within my form. This dot props dot filter completed is also not defined in my form. I want this dot props dot filter to dos. Right? This is the prop that I am naming, so I get it with this dot props dot filter to dos. So it can be helpful to keep your names consistent so you don't make mistakes, but it is not necessary. So now when I click clear completed, we run that function, which is going to filter out any of the completed to-dos and leave our list clear. So let me just add some more, and I can complete some number of these, and then when I click clear completed, those all get removed. So, any questions with this? No, we're feeling good about that? Alright, well if there are no final questions, then I'm going to wrap this up for today. And I'll see you all in after hours tonight. I did not have enough time to get to, some people had requested that I go over the replit from today. Who was that? I know that was Eli, but also Mary. Are you both here? Because if you are here, then I can just keep going. I see Eli. Okay. So what I'm going to do is I'm going to call this for now. If any of you are interested in seeing the solution to the breadth search replit, I'll do that now. But if you're not, please go and work on your afternoon project. So I'll do that now, and I can do it again later if people show up. So let's find our replit. So I'm going to go back to when I was a student, back in the olden days, and grab it from there. And we're going to ignore my solution because it has some complicated bits that we really don't need to care about right now. So let's see, this was breadth first search. Okay, and we're going to hide what I did. So the idea here is that we're writing a function that accepts a tree-based data structure and then searches for a value inside there. So first, let's talk about a tree. And I'm going to pull up a drawing program. Because if you haven't seen a tree before, it's pretty fundamental to computer science. And I also want to make a funny joke. But it's really important when we're dealing with these kind of strictly algorithmic things to draw pictures and understand what's happening. So, alright. So here is our empty document. So a tree structure is like we see on the right hand side here, this object that has keys, and inside of these keys there are sub-objects, and eventually they terminate into values. So there's different kinds of trees, but basically they look like this. We have nodes, and these nodes can connect to other nodes. And these nodes can further connect to other nodes. It doesn't always have to be two. In some trees it is, in some trees it's not. In some trees each of these nodes have values. In our tree right here, only the leaf, the final end point of each of these branches has a value. So these eventually end here. So what we're going to do is, let's say, this is 2 and 3 and 4. So if we want to search this tree, there's different methods of doing so. And let's call this 5. So the two main algorithms for searching this tree are depth first search and breadth first search. Because when I get to this tree and look at it from the top, I can either check out this entire row first. I can check out all of these to see if they contain the value I want. And then go down here and check out all of these to see if they contain the value that I want. That's called breadth first search. We're doing it kind of layer by layer. There's also depth first search, which is going to have us, okay, I'm just going to drill all the way down until I get to this 2 and check that out. And then I'll check out its siblings, and when I'm done with this branch, I'll go and check the next one. That's called depth first search. We drilled all the way down till we get a value. And then we start moving back up and going back down, whereas breadth first search is our kind of row by row approach. So that's breadth first search and depth first search. We're going to be implementing breadth first search. So what we want to be doing is, let's open up a Scratch file here. I'll zoom in, and let's open up a REPL. Okay, so I'm going to write a function called breadth first search. It's going to take in a tree and the value we want to search for. Let's call it tree and value. And what we want to do is we want to, let's see, what does it expect us to return? Okay, so it just wants to return true or false depending on whether we found this object or not. Or I'm sorry, this value or not. So the way we're going to do this with breadth first search is we want to keep track of all the nodes that we want to visit, and then decide the order that we're going to visit them in. So this requires knowledge of an additional data structure. Because what we're going to do is we're going to start here, and then I'm going to get all of the children of this. And I'm going to say, okay, I'm going to need to search these eventually. And when I search this one, I'm going to see, oh, it has additional children. I'm going to grab all of those. I'm going to search those eventually too, but for now I'm just going to keep heading this way, and then when I'm done with this, I'm going to go and search these children. Whereas with depth first search, what we'd do is we'd start here, we'd look at its children, we'd see this one, and we say, I'm going to search this now. And we'd go and we'd search all of its children, and then when we're done, we'd pop back up here, see that we had another child, and we'd search that. This highlights two very important, very fundamental different data structures, the stack and the queue. The queue is what we're most familiar with when we think of lines. So if we're at a store, you know, and there's a person behind the register, we line up in a queue. This is also known as first in, first out. The first person to get into this line is the first one served, and the last person to get in is the last one served. There's also a stack, which is literally a physical stack. We put, you know, books onto a stack, and if we want to get a book, we have to take the top one off. So this is a last in, first out situation. It's not, you know, the first person in the line gets served, it's the last thing that we put onto here gets served. This stack is what we use in depth first search. The thing that we're looking at right now, that's what we want to do immediately. But with our queue, what we're going to do is going to say, okay, I see these, I'm going to add them to my queue, I'm going to add this to my queue, and I'm going to get to them in order. That's our breadth first search. So, what we're going to do is we're going to define a variable called queue. And it's going to be an array, because conveniently in JavaScript, we have the ability to treat an array as either a stack or a queue. So we're going to write our queue. And then what we're going to do is we are going to check and see if our queue is empty. While queue.length is not equal to 0, then I want to keep searching within my tree. And if I don't find anything, then I'm going to return false. So what I need to do is I need to initially put some values in my queue. So what I'm going to do is I'm going to get all of the keys out of my tree, because those are the children. Those are the nodes in the tree that I want to search initially. So I'm going to set the queue initially to be the values in my tree, which I'm going to do in a way that's not super efficient, but I just kind of want to illustrate that this queue is an array, so I'm going to leave this here. So I have a function called object.keys, which, when given an object, it returns me an array of all of the keys inside that object. So then I'm going to push them onto my queue. I'm sorry, I'm going to map over these. Actually, I'm going to for each over these and get each key, and then I'm going to push that key onto my queue. So let's stop here, and let's define and run our function. So let's see, let's do breadth first search, and then I'm going to call this with a tree that has just A, B, and C in it. And this value doesn't have to be anything. And instead of returning false, let's return queue. Alright, so when I run this, we see I have an array with all of these keys in here. A, B, and C. So now what I want to do is I want to search each one of these. If it's some value, I want to check and see if it matches the value that I'm looking for, and then return true. If it's another object, if it's another, tree that has child nodes to it, then I want to add that to my queue. So the first thing I want to do is I want to take the first person in line. With breadth first search, I want to go in order. So the way I do that is I could do something like const item is equal to queue at 0. But then I'm going to later need to figure out how to remove the item from the queue when I'm done looking at it, and it turns out that there's a function called shift. And what it does is it returns the first item in my array and also removes it at the same time. It's basically the queue equivalent of pop. When we have a stack, we have this data structure, and when I want to get the last element, I pop it. And that will give me its value and then remove it from my stack. With a queue, when we process the first person in line, that's called a shift in JavaScript. So we're getting the value of the first person in line, and we're also removing that from our array. So that's queue.shift. So that's going to be the value of my item. Then I want to check the type of that item. This solution isn't going to be robust in the sense it won't be able to tell. You know, we can't check and see if the value is another object. I'm just going to be working off of, like, if this is an object, then I assume it's a tree that has more children, and value is going to be some primitive like a number or a string. So we're going to get the type of our item, and if that is equal to an object, then yes, so Eli just asked, do arrays show as objects? They do. If we do type of an object, we get object, and if we do type of an array, we also get object. And the reason is, we can really think of arrays as objects where the keys are indices. In fact, if I do object.keys and give it an array, we get 0 and 1, right? Because those are the keys in our array. We access keys from objects, you know, using the same syntax that we access keys in our object. Yes, Mary, we could initialize the queue directly as object keys trees. I'm just going to use this later, so I'm going to leave this here for now, and then I'm going to go and refactor it later. Because what I want to do is, if this item is an object, then I want to add each one of its keys to my queue. And I'm going to add them onto my end, and I'm going to deal with them later, because I want to search breadth first. I want to deal with each layer at a time. And now that I have added this where it actually needs to go, I can refactor this line. And added a nice little comment there. So now, if my item is an object, I'm going to add each one of its keys in my queue to be processed. And we run into, oh shoot, yeah, this is where my solution differed from the solution they provided, because the key-based thing doesn't actually work here, which is the way that I would want to do it. You have to use how did they do it in their solution again? Instead of doing keys, they just put the whole object in the queue, right? That is what they did. That is what they did. Okay. So my key-based solution was neat, and the way I would write this in a different language, but in JavaScript, we're not actually going to use the keys. I'm sorry, we're going to backtrack a bit. What the queue is going to be is, instead of an array full of keys, it's actually going to be an array with our tree in it. It's going to have the literal nodes that we want to search in there. And we're still going to do, if our queue still has stuff in it, we're going to shift the first item out of our queue. And if that item is an object, then what we're going to do is we're going to add all the nodes, all the child nodes of this that we want to search to our queue. So instead of getting the keys, we're going to get the values. If I change this, where was this? Didn't I do? Oh, I guess I didn't. So let's do object.keys of A of 1 and B of 2. We get the keys. If I do values, then I get the values. And if those values happen to be objects, then they happen to be objects. And I can search those from within there. Eli, your solution to dynamically add brackets isn't we wouldn't be able to do that. What I did, because I wanted to do the key-based solution, because that's how it initially occurred to me, is I wrote a function called getIn, which takes an array of keys and then accesses those keys one after another on the object using a reducer. Which I can post this solution later, but I think actually using the JavaScript that we know, using this node-based solution is actually better, even though my first intuition was keys as well. So we just put the node directly in here, and if the item is an object, we're just going to put all of those values directly in our queue. And if our item is not an object, what we can do is we can check it against our value, and then if the if the value is equal to our item, we're going to return true. And I'm missing a closing curly brace there. So what we're going to do is we are going to start at the root of our tree. We are going to get it. We're going to check and see if it's an object. If it is, we're going to add all of those nodes inside of that tree to our queue. We're going to recur. If that node happens to be not an object, a primitive value, we're going to check and see if it equals the value we are given. If it is, we return true. We're going to repeat over and over and over again until we run out of items to check in our queue, in which case we will exit the while loop and we'll return false. So let's see if I have any bugs in here. Okay, so let's call breadth first search on an object. Let's do a simple one, A of 1, B of 2, and let's search for 2. We get true. Cool. Let's search for 3. We get false. All right. Now let's try to drill in and use some sub things. So what if A has a sub tree in it where C is 3? Oops. That's running for way too long. Please don't crash my computer, JavaScript process. Uh-oh. Okay, there we go. Yeah. What bug did I make? Let's just quit all processes of my editor. There we go. So we always got to be careful that we are defining our base cases correctly. Oh, I know what I did. I know what I did. What if we do type of null? We get object. So I was never actually terminating, because if we did a shift on an empty array, we were getting undefined. And if we do type of undefined, oh, that is undefined. Why wasn't that terminating then? Because that should do that. So let's put some console logs in here. Let's console log item, And then I'm also going to add if the item exists and it is type object. So then let's send this region over, get this defined. And then let's run our breadth first search on A, where A is C, and that is 3. And then we also have B, and that is 2. And let's search for 3. Okay, so that is indeed never terminating. So let's kill that buffer. Okay. So why was that never terminating? So we are shifting off of there. Do. Alright, I'm going to do this instead. I'm going to run breadth first search on our tree, where A is C, and that is 3, and then...
Maybe object.values item instead of
Yep.
object.values tree.
Yep, I just saw that right as you commented that. Yep, because I'm always getting the values off the tree instead of getting the values off the item. And that should fix it. So let's define that region. And then let's call breadth first search on A, where A is C, and C is 3, and then B is 2, and then we're looking for 3. There we go. So first we search the whole tree. We don't find anything. We search as children. Or, I'm sorry, so we get the whole tree. So then we search its first child, which is A. It's an object. We're going to add, let me also console log our queue so we can see this executing. Oh. So then let's run this. So we can see we start with our tree and an empty queue. Then what we're going to do is we're going to look at the first child. And we see that, I'm sorry, okay, so we're going to start with our tree. Our tree is an object, so we're going to add all of its children onto our queue. So we're going to have this object C of 3 in there, and then our object B of 2. Then we recur. In this next iteration, we shift the first item out of our queue, which is this object, C of 3, which is an object. So we're going to put all of its children inside of our queue, and we're going to recur. In this iteration, we shift out the first item, which is going to be 2. That does not match, so we recur. In this case, we shift out 3, which is the first item in our queue, and then we're going to return true. So that is our breadth first search. We just search each line across using a queue as our underlying data structure, which is going to serve, it's going to check things in the order in which they were added, instead of depth first search, which is going to use a stack as its underlying data structure. It's going to search whatever we just looked at. It's going to keep drilling all the way down, and then move back up, and then go down again, and pop up and down like that, whereas breadth first search, just moving across each line. So, any questions with this?
You explain it well, thanks.
Okay, great. Replit complains about making a function within a loop. Yes, it doesn't like that we're using this anonymous function right here, because every time I execute this while loop, it's going to redefine this function here, which is just wasteful. So I might as well be like const, and I should rename these from keys to be values. So I could be like add value, and this is going to take in a value, and this is then going to do q.push with the value. And then instead of using my anonymous function here, I can just give it my add value function. And this is going to work exactly the same, but now I've only defined this function once instead of defining it within each iteration of my for loop. And this is going to be more efficient because we're not redefining a function unnecessarily. That's why Replit was yelling at you. Because potentially if we run this while loop thousands of times, then yeah, that's going to add up. But for our kind of toy problem, it doesn't really matter too much. So, any other questions with this? Okay, great. Well then I'm going to call this. Have fun on your afternoon projects.